where it's given that an electron is moving into the xy plane. Okay, so let's say this is the xy plane. Yeah, let's say if this is the xy plane, right? This is x and this is y, and that electron is moving into that xy plane, right? Let's say this is the electron whose velocity is represented with this arrow. Okay, if this is the velocity of the electron, then in the question it is asked that an electron moving into xy plane with a speed of 10 power 6 meter per second. So the velocity of the electron is given as 10 power 6 meter per second, right? This is the data given to you. Now, apart from this, what is given? Let us see. Its velocity vector makes an angle of 60 degree with the x-axis. So if this is the velocity vector of this electron, then it makes an angle of 60 degree with the x-axis, right? This is the data given to you into the question. Now, it's also shown that there is a magnetic field of magnitude 10 to the 10 power minus 2 Weber per meter square, right? So there is a magnetic field, and that magnetic field is 10 power minus 2 Weber per meter square, right? And that magnetic field is acting directed along the y-axis, right? That means B is acting along y-axis like this, right? B is acting along y-axis. So the magnetic field is acting along y-axis, and the velocity vector is making an angle of 60 degree with the x-axis, and in this way we need to calculate the magnetic force exerted on the electron. I mean to say, due to this magnetic field, some force is exerted on this electron, and that magnetic force need to be calculated, right? So let us write what we need to find. Magnetic force exerted on the electron is what? That we need to calculate. Now students, just do one thing. We know the relation, the force exerted due to any magnetic field on a charged object if V F is equal to QV cross B, right? Where you can see V is the velocity vector, B is the magnetic field, and Q is the charge of that electron, right? Now here what we can see, this is a cross product, so we can write it as QVB sine theta, where theta is the angle between this V and this B, but B is acting along this direction, y direction, so therefore this will be the theta angle. So here it's given that this is 60 degree and this is 90, then theta will be 90 minus 60, so theta is calculated as 30 degree, right? So for theta equal to 30, this sine theta will be sine 30, right? So we can write it, the charge of an electron, you know the charge of an electron is what? Minus 1.6 into 10 to the power minus 19 coulomb, right? This is the charge of an electron, you remember it, right? So just put up the value Q in place of Q as minus 1.6 into 10 power minus 19 coulomb, right? This is multiplied with V. What is the velocity? What is the V? So V is the velocity which is having component what? You can see 10 to power 6 meter per second. So just write the value only, 10 power 6. So this is V and this is Q, and this will be multiplied with what? Q taken V taken B. What is the value of B? B is given as 10 to power minus 2 Weber per meter square. Is 10 to power minus 2 Weber per meter square, right? Multiplied with, so B is also taken. This is B multiplied with sine theta. What is the value of sine theta when theta is 30 degree? It's sine 30, which is 1 by 2, right? So this is sine theta. So I just mentioned here like this so that you can understand that this is this value of Q, this is the value of V, this is the value of B, this is the value of sine theta, right? So multiply all these together. So, and just take into your mind that what will be the velocity, what if the velocity vector is marked over here, you can see V, right? And this is magnetic field marked into y direction, right? Then you can see the component of V, which are broke into two part, I and J, that is V sine 60 over here and V cos 60 over here, right? So you can see the components of the velocity vector here is, here you can see V cos 60 here and V sin 60 here. What I meant to say that the component over here, since I and J component will be in cross product, and this will give you the K. So in the resultant only K will be available to you, and this much of Newton is applied, but that will be into the K direction, because if I cross J, it's coming out of the page here, so the force will be exerted out of this page, right? So into the K direction the force will be applied here into the K direction. So force is applied into the K direction, right? And the value is just simply, you can calculate it. You can see minus 1.6 into 1 by 2 divided by 2, that means it will be minus 0.8 into 10 to the power minus 19 and 6, it will give you 10 to the power minus 13, right? Here 10 to the power minus 2 again, so this will give you 13 to 15, so this will give you 8 into minus 8 into 10 power minus 16 Newton of force into the K direction, but it's minus, so we can write it 8 into 10 power minus 16 Newton into minus K direction. That means this should not come out of the page, this should go within the page like this, minus K. If this is K, minus K will be reversed to that, right? So this is your answer, and in this way we have solved it. If you like it, students, you can, if you find it useful, you can just like and subscribe. Thank you so much for watching. Bye bye. Take care.